So welcome to the Introduction to L'Hopital's rule, a very, very common question type in maths exams. Now, before we go through all of this, let's just have a look at what it is that we're talking about. Let's take a simple example of a limit. Let's imagine we have the limit as x approaches 3 of x squared minus 4 over x minus 2. Okay, well, all we do is we need to put x equals 3 into there, and that gives us 3 squared minus 4 over 3 minus 2, which equals 5 over 1, which equals 5. No problem at all. Okay, we don't need L'Hopital for that limit, but let's just change it slightly and we'll see why and when we might need L'Hopital. So let's have a look at the limit when x approaches 3 of, let's just change it slightly, to x squared minus 9 over x minus 3. Now let's do exactly the same thing, put x equals 3 into here, and we get 3 squared minus 9 over 3 minus 3, which is 0 over 0. So we don't know what this limit is because this is called indeterminate. It's 0 over 0. And this is where L'Hopital comes in. So now what we can do is we can go back up to our definition here. So what it is saying is if we have a function of x over another function of x, and when we put x equals to a in those two functions, we either get 0 over 0 or plus or minus infinity over plus or minus infinity. Then we have indeterminate form because we cannot determine indeterminate form because we can't determine what the limit is. And then we use L'Hopital, and what L'Hopital says, well, if the limit of f of x over g of x is indeterminate, then what we can do is we can differentiate the top and we can differentiate the bottom, and the limit of the two differentials when x approaches a is the same as the limit of the original two functions, and so that is when we can use it. Now, in our case, let's do this case here. So we have here an indeterminate case here. So what L'Hopital is saying, well, hang on a sec. If the limit of f over g, and there's f and there's g, is 0 over 0 or plus or minus infinity over infinity, what we can do is just differentiate the top and the bottom. Okay, so that is going to equal, our limit here is going to equal the limit as x approaches 3 of the differential of the top, which is 2x, and the differential of the bottom, which is 1. And therefore we can now stick x equals 3 in, and that equals 6 over 1, which is 6. So we have now found the limit of x squared minus 9 over x minus 3, even though sticking x in directly gave us an indeterminate form 0 over 0. By using L'Hopital and differentiating the top and the bottom, we get a limit which is not indeterminate, and then we can say by L'Hopital the limit of the original thing is equal to the limit of the derivative. And there we have it. Okay, so in actual fact, this particular one we can check just as a little side note, because the limit as x approaches 3 of x squared minus 9 over x minus 3, well, x squared minus 9 by the difference of two squares is x plus 3, x minus 3, so that is x plus 3, x minus 3 over x minus 3, and in actual fact that cancels out, leaving us just with this, which can be evaluated as x approaches 3, just sticking x in there, and that gives us again 6. Okay, so basically what we're going to do is, before we carry on doing some more analysis of L'Hopital's rule, let's just give a very, very informal proof, because I find that having some idea of what the proof is, and we're only going to do an informal proof, and it's only going to be for 0 over 0, but just seeing the proof just helps understanding. So let's have a look at the definition of a derivative. Basically, so f dashed of a, i.e. the derivative of f of x at a, is equal to the limit, this is just by the definition of derivatives, x approaches a, of f of x minus f of a over x minus a. And you may have seen this actually as a slightly different form. You might have seen it as f dashed of x is the limit as h approaches 0 of f of x plus h minus f of x over h, but it's the same thing. Basically, this is just the standard definition of the derivative. Now let's have a look at the case where we can use L'Hopital. So we're looking at the limit as x approaches a of f of x over g of x equals 0 over 0, so it's indeterminate, i.e. that means that f of a is equal to 0 and g of a is equal to 0 as well. So let's rewrite f of x over g of x as f of x minus f of a, because f of a is 0, over g of x minus g of a. And we can further rewrite that as f of x minus f of a over x minus a over g of x minus g of a over x minus a. And so therefore, the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of this thing here, which is, let's rewrite it, f of x minus f of a over x minus a over g of x minus g of a over x minus a. But this thing here is f dashed of a, and this thing here is g dashed of a by definition of derivatives. Here, this thing here. And therefore, we have that the limit as x approaches a of f of x over g of x, when that equals 0 over 0, then it also equals the limit as x approaches a of f dashed of x over g dashed of x. And that's where L'Hopital comes from. It is a little bit of an informal proof, but it gives you an idea. Okay, now moving on, L'Hopital only works on indeterminate forms, going back here, only works on indeterminate forms 0 over 0 or plus or minus infinity over plus or minus infinity. It does not work on a form like 0 times infinity or 0 times minus infinity. It doesn't work on that. However, what we can do is with a little bit of a rewrite, we can turn any expression which has this indeterminate form, because 0 times infinity is still indeterminate. We still can't determine what that means, but on what it evaluates to, but we can't use L'Hopital on that form. We have to convert it to something else. And the way to do that is easiest shown by an example. Let's imagine we just have an example here. The limit as x approaches 0 of x log x, for example. Okay, so let's have a look. Well, putting x equals 0, that equals 0 times, well, a log of 0 is minus infinity. So we have 0 times minus infinity, which is indeterminate, but it's not in the form 0 over 0 or plus or minus infinity over plus or minus infinity. Therefore, we can't use L'Hopital to evaluate that. So what we do instead is we turn this into another form. Well, of course, x is equal to 1 over x. So we can rewrite this as the limit of log x over 1 over x. And now, when we look at the limit there, we have that limit is equal to minus infinity over infinity, which, hey presto, is now in a correct indeterminate form so that we can use L'Hopital. So in actual fact, we can do this. Why not? Let's finish it off. So we have the limit of as x approaches 0 of x log x. That's the same thing as the limit as x approaches 0 of log x over 1 over x, which we have just established is minus infinity over infinity, which is an indeterminate form in which we can use L'Hopital. So now what we can do is we can differentiate the top, differentiate the bottom, and that limit is equal to the limit as x approaches 0 of the differential of log x, which is 1 over x, over the differential of 1 over x. Well, 1 over x equals x to the minus 1, so the differential of that is minus 1 over x squared, and tidying that up, that equals the limit as x approaches 0 of minus x, just tidying this bit up here, and of course now we can just put x equals 0 in there, and the limit is equal to 0. And so therefore, by working out the limit of the derivative to be 0, we now know also that the limit of the original thing is equal to 0. So that's how we could do that. And often they do ask questions where the indeterminate form is not in the correct form for L'Hopital. So you have to use this little trick, basically looking to put one of them as a reciprocal on the bottom instead of the top. Okay, now one other thing before we move on to answering questions, sometimes you have to differentiate more than once. And I'll just give an example here. It is a little bit complicated for an introduction perhaps, but anyway, so let's have a look. So we got the limit as x approaches 0 of 3 sine x minus 4x cos x add x over x cubed. Now let's have a look at this. So basically when we put x equals 0 into this, we get 0 minus 0, add 0 over 0, so it's 0 over 0, so it's indeterminate, so therefore we can differentiate top and the bottom and use L'Hopital by L'Hopital's rule, so that equals the limit as x approaches 0 of, differentiating the top, or the differential of 3 of sine x is cos x, differentiating this bit here by the product rule gives us cos x minus x sine x, and differentiating that x is 1 over 3x squared. So we've done the differential once, but now when we put in, let's just tidy that up. So that gives us the limit as x approaches 0 of minus cos x add 4x sine x add 1 over 3x squared. Okay, now when we put in x equals 0 again into here, what we find is, well, that's going to be minus 1 add 0 add 1 over 0, which again is still 0, 0, indeterminate. So what we can do now is we can differentiate again in order to find. So basically let's differentiate the top and the bottom. Okay, well the differential of minus cos x is sine x. Again, we've got to use the product rule here. Differential of x sine x gives us sine x add x cos x over 6x. We've differentiated the top and we've differentiated the bottom, and let's just tidy that up a little bit. That gives us 5 sine x add 4 x cos x over 6x, and now let's put x equals 0 in. Well, that gives us 5 times 0 add 0 over 0, which is still 0 over 0. And so we've got to differentiate again. We can use L'Hopital again. So now let's have a look. Finally, limit x approaches 0. Let's differentiate again. Differentiating the top gives us 5 cos x add 4 cos x minus x sine x by the product rule. And on the bottom, we now have 6. And when we, let's just tidy that up, that gives us the limit as x approaches 0 of 9 cos x minus 4x sine x over 6. And now when we put x equals 0 in, finally we get that equals 9 minus 0 over 6. Finally, it's not indeterminate. It equals 9 over 6, which is 3 over 2. And we have finally found our limit, and we can go all the way back up to the original question, which was here, and the limit of that is equal to 3 over 2, and we've actually had to use L'Hopital 4 times, or is it 3 times? 3 times in order to get our limit. Okay, now I know that's a little bit complicated for an introduction, but you get the idea. You can keep using L'Hopital as long as you keep getting indeterminate answers. For the rest of this podcast, we're going to dive straight into exam-style questions. What we've covered in this introduction pretty much covers about 90% of situations you will find yourself in exams. Hope you found this useful. If you have, please like this video and subscribe to the Gresty Academy YouTube channel. Thank you.